Welcome, everyone, to our fifth in the series of six webinars on Bayer Beyond the Basics. This afternoon, we're going to have Dr. Mike Fidanza talking to us on a subject that affects all of our spray applications, preparation and decisions concerning spray equipment, water volumes, tank additives, and timing. I just want to let you know, at the end of today's session, there will be a questionnaire. It's a very short questionnaire. If you could take the time to give us some responses. And one of the things it's going to ask you is suggestions for future topics. So if you feel that these are worthwhile and you have a favorite topic, please make that suggestion. This afternoon, if you have if you've got more than one person that's attending this online, make sure and let Veronica know the other attendees. For this would be like if you want GCSAA credits for education, that's the only way that we will know if you did not log in with your own identification. Also, everyone's in listen mode. So over on the right side, you'll be able to type in any questions that you have, and at the end of the webinar, we will address all of your questions with Dr. Fidanza. So make sure you turn those in. If you have any technical difficulty, you can see the last bullet point there that you can type your issues into the Q&A panel, and a technical support person will assist you, and you can write down this 866-229-3239 if you have issues with the webinar and need to talk with someone live. Just a reminder, our last in our series for this year will be on November 15th at 3 p.m., and this will be on maintaining healthy turf in a nematode environment. So hopefully you've got that on your calendar. If you do want GCSAA CEUs, you can, if you've registered, you can expect the information to get out to you within the next 6 to 10 days. And if you're a Bayer Accolades member, you will get 2,000 Accolades points for this session, and you can receive 4,000 bonus points if you attended 4 or more sessions in our series. And now I'd like to introduce Dr. Mike Fidanza. Dr. Fidanza is Professor of Plant and Soil Science at Penn State University. He actually started out 5 years in research and development, and then went to Penn State and has been there since. And we look forward to Dr. Fidanza's presentation. Go ahead, Dr. Fidanza. Thank you.
Okay. Hey, thank you, Mr. Johnson. I appreciate that introduction. Hey, thank you, Veronica, from the Bayer Attorney Agency for helping me out with a lot of the technical issues here. Thank you also to Bayer. Yeah, there's a little history. I graduated, 1995, working under Dr. Peter Dernodin, survived that, and took a job right away with the Herx Corporation in research and development. A lot of fun. And through a couple of mergers with Rome Plunk and other companies, now they're the Bayer Group or the Bayer Company. So there's a little bit of a lineage there. So I'm glad to be part of this web seminar. A few minutes ago, I had a student knock at the door frantically, and I had to step away for a minute. I teach one of the courses I teach this semester is an undergraduate course in botany for non-science majors. I have 120 students. And tomorrow's the first exam, so there's a tremendous amount of panic. There's students that are suffering from various viruses and colds and flus. So these exams that I give, I think, causes this kind of stress. So I had to calm the student down, and it's going to be okay. So these things happen with these undergraduates. But I'm located at Penn State's Berks campus in Reading, Pennsylvania, outside of the sort of west of Philadelphia, southeastern part of the state. and we have about 3,000 students here. Penn State University Park, the main campus, it's the center of the state, and that's where the majority of our turf program is up there. But anyway, like I said, I'm here in the eastern part of the state of Pennsylvania, and it was raining this morning, and now it's sort of cloudy and overcast. So hopefully some folks are sitting and listening in. So I appreciate your time. So this seminar, I work with Dr. John Kaminsky at Penn State University Park. We deliver this seminar at the GIS every year, and so this is sort of an abridged version of that. So let's see here. Get my all right. So this is just again example of making applications, whether it's fungicides, herbicides, insecticides, plant growth regulators, and it was largely ignored up until a few years ago. But we started looking at some opportunities to improve fungicide efficacy, and we started looking at this machine here, looking at the sprayer, looking at the nozzles, looking at the product inside the spray tank. There's different companies and folks involved to all make this thing work, and a few years ago, no one really was talking to each other. The folks that manufacture the product weren't talking with the people that make the sprayer, weren't talking to the people that make the nozzles. No fault of their own, they just weren't getting together. So now we've got this sort of conversation, dialogue started. So let's talk about potential reasons for disease control, and I'll focus on fungicides. And you look at potential reasons for failures, but also opportunities to improve the performance of these products. Now, fungicide resistance is a serious issue, and we could spend a lot of time talking about that. Sprayer calibration, sprayer equipment. I've seen problems with misapplication and product failure just because sprayers weren't calibrated properly or equipment wasn't cleaned properly or maintained as good as it could be. Application water volume, sometimes making a little adjustment in water carry volume can mean a lot. Where to target the pathogen, a foliar disease versus a root disease, preventive versus curative applications, etc. Sometimes it comes down to nozzle selection. Pretty inexpensive piece of equipment, but can make all the difference in the world. And so anyway, there's other factors involved, something to keep in mind. Now, I'm not going to make this a fungicide chemistry class, but if you look at turf fungicides, most of them are site-specific, and we have just a few multi-site compounds. And so we have to think about this or keep this in mind, when you're selecting your fungicide products and developing your fungicide programs and how they're delivered. And so for more information about these fungicides and their mode of action or site of action, I just want to nudge you toward these sites. The Fungicide Resistant Action Committee website, FRAC, they have a list of all the fungicides used with their FRAC codes. And the families of fungicides for turf is available at the Ohio State University on their website. I think Oregon State has a fact sheet, and some other universities. This is a real convenient 1 or 2 page sort of sheet with all the fungicides, turf fungicides listed, their chemical families, their resistant risk. It's really a good resource to have. Okay. So FRAC info or Buckeye Turf, there's other sites available as well. And this is what it looks like. You have these FRAC codes listed on the far left, and the product trade name, the chemical family, and the resistance risk. Okay, these FRAC codes are designed to help you when you plan your fungicide programs, and also to give you an idea of the resistance risk associated with these particular compounds. Okay, and also the reason why I want to bring this to your attention as well is the FRAC codes are also listed on your fungicide labels now. You'll see them on the products, and it's for example here this is interface fungicide, and it says here group 2/11 fungicide. There's 2 active ingredients in there. So this will help you, the end user, to determine your fungicide spray program. So these things are designed to again improve our efficiency and minimize the risk of fungicide resistance. Okay, so I just wanted to bring that to your attention. Let's see. As far as fungicides go, we have preventative options and curative options, obviously. And in recent years, there have been reduced efficacy in fungicides, maybe due to microbial degradation of certain products, resistance issues, but I think more importantly, restrictions on application rates and intervals, some products being removed altogether. So there's all these outside pressures, on our products, fungicides and other plant protection and plant health products that we have to keep in mind. Okay, and now if you suspect fungicide is resistance at your site, okay, and again, it's not cut and dry. Sometimes you need to work with your local university or cooperative extension specialist, work with your distributor and the manufacturer of the product. It involves collecting samples, sending them off to a lab, conducting a detailed assay and analysis to determine just the degree of resistance if it does exist. I will say early on when we started doing this work, there was some question about a particular fungicide and with in terms of resistance issues. And this particular fungicide has no known history of resistance. That's where we started looking at delivery method and water volume, and there's so many other aspects of this, of applying a product before we call it resistance. There's other things we have to rule out. But if you do suspect resistance, again, work with the resources there in your state and your region and really determine the level of resistance or not. So just a friendly reminder there. The other thing is calibration. Okay, this is a good friend of mine, superintendent. He's been a superintendent for like 36 or 37 years now. He's a legend here in the southeastern Pennsylvania region. And I was working with him one day on fitting different nozzles onto the sprayer and going through a couple of calibration exercises. Okay, I assure you there's water in that spray tank, even though he has his cup of coffee here and all that. There's only water in the spray tank, so everything's nice and legal here. Okay, so we went through an exercise, and it's great if you have hire a summer intern or summer student to have him or her go through this for you. I don't know if that's something as superintendents do themselves or have their assistants do this, but definitely check the pressure and nozzle spacing, boom height, nozzle type, how much water is coming out of those nozzles. If you want to apply water volume at 1 gallon per 1,000 square feet or 2 gallons per 1,000 square feet, is it calibrated properly? Okay, your ground speed, determines do you have to travel at 3 miles per hour to get 1 gallon of water per 1,000 or 3.5, et cetera. So the calibration of your spray equipment is very, very important, and definitely take time to do that. Write down everything and the gear and the nozzle type and the water volume, pressure, et cetera. Anyway, hopefully you're doing this on a regular basis. How often do you calibrate your sprayer? It's a question for you. Is it once a year? Is it once when you got the sprayer and it hasn't been calibrated since? Again, this is a great exercise if you hire some summer students to have them learn how to calibrate a sprayer. We teach it in class. I teach an introductory turf science course, and we go through a sprayer calibration exercise, but that's just one time. I think it'd be great to get these students more experience on calibrating your sprayer. You want to maximize the value of these products being applied. Okay, you want to make sure if your spray is calibrated properly, you'll definitely ensure that the label rate is being applied or the proper rate's being applied. Also, minimizing your turf graze injury or phytotoxicity. Maybe not an issue with fungicides, of course, certain times of year, certain types of fungicides, but definitely herbicides and plant growth regulators. You don't want to over-apply some of these products, okay? And then most importantly, you want to minimize disease control failure, reduction in disease control if you know your machinery and your equipment is operating properly, okay? So some things to consider with sprayer calibration. Are all your nozzles alike? I've seen sprayers with different nozzles on them. I understand if you're in a hurry and a couple of nozzles are clogged, you can grab a few nozzles off the shelf, but that can impact your application delivery. Check for blocked nozzles or nozzle screens. Okay, there's all kinds of mechanical and electronic functions of your sprayer that need to be checked. So, and the other thing is, it's definitely you want to make sure you keep accurate pesticide and fertilizer records. Okay, I know several golf course superintendents who were visited by their state Department of Agriculture pesticide inspector, and it's something that you make sure you have these records up to date and accurate. Even myself, as a university researcher, I also have to keep pesticide and fertilizer application records just like you do. Okay, so don't forget equipment maintenance and repair. And then the bottom line, though, with making these applications of these products, especially with fungicides, coverage is very, very important. And don't let the incorrect sprayer calibration or machinery failure or equipment failure be the reason why you have poor fungicide coverage. Okay. So let's see, application water volume. Let's talk about this. Let's see. The general rule of thumb, and you could agree or disagree. Think to yourself about this question. How much water do you use on your fairways and how much on your greens? And the general rule of thumb is 1 gallon of water per 1,000 square feet fairways, about 2 gallons for greens, and that's about 44 gallons per acre fairways, about 88 gallons per acre greens. Now, ideally, I'd like to have a little more water on fairways, and even 50 gallons per acre, and for greens, 80 to 100 gallons per acre on greens. I think water volume on greens is more important for coverage. On fairways, that's about as much water as you can get. There's an awful lot of water to move across those acres of fairways, so more than 1 gallon or 50 gallons per acre, that would be an awful lot of water and take a lot of time. But for greens, though, I think we can promote 2 gallons of water per 1,000, or maybe 80 to 100 gallons of water per acre. That's a real good number to shoot for. So you think about application water volumes, 1 gallon per 1,000 square feet. What does that equate to? 128 fluid ounces per 1,000 square feet, or about 4 mils per square foot. Or I like to relate it to a shot of whiskey, is about 25 mils. Okay, so think about how many square feet that'll cover. So that's why water volume combined with the nozzle selection, you have to formulate those droplets and evenly apply those products and materials to that site. And what are you targeting? Are you going after a disease that's affecting the leaves and the canopy? Is it down into the crown and stem base? Is it a root pathogen? Okay, so not only is uniform coverage on the surface important, but also maybe moving the product down into the crown, into the root. Okay. So anyhow, sort of a rule of thumb here with foliar targeting foliar diseases, coverage is important. We don't have the luxury, you're not spraying 800 acres of corn or soybeans. You're spraying a green that every square inch of that green has to be covered. Okay, you can't afford any gaps. So that's why coverage is important. Diseases that affect the stem base and crown, you want to apply a little higher water volumes to sort of not really wash the material in, but rinse it in. And then roots, this is where you make the applications, and you're going to have to use some post-irrigation to really sort of move that material down to where it needs to go. We'll get into this in a little more detail. And think about a fungicide's phytomobility. That's from Dr. Rick Lattin's textbook that just came out. He talks about fungicides being either contact or penetrant. Now, contacts are basically surface coverage is very, very important. Okay, the fungicide material sits on that leaf and it protects that leaf. But your penetrants have some mobility to them. There's localized penetrants, enters the plant, and there's minimal movement. There's acropodal penetrants. Most of our sort of systemic type, as we call them, fungicides are actually acropodal. They move up at the point of contact or move up in the xylem. Then our true systemics move throughout the plant. Okay, so think about a fungicide's phytomobility, and those FRAC codes and that kind of information can help. Now let's select a nozzle. Okay, this is really interesting because the last piece of equipment to come into contact with those plant protection products, that's the nozzle. Okay, and I've seen some spray tanks. I'm not saying anybody listening in has done this. I've visited golf courses where there are 11, 12 different products in the spray tank. And that's an awful lot of money in that spray tank, okay, to treat the fairways or the greens. and so you don't want to mess that up. You don't want the nozzle to be the reason why all those products didn't work. Okay, so years ago, I mean, we didn't really have much choice in terms of nozzles, but in the last 10 years, we've come a long way. I want to point something out to you. These hollow cone spray pattern, these hollow cone nozzles, these nozzles produce a hollow cone spray pattern, sometimes a flood jet type pattern. We shouldn't use these at all for turf, okay? Because they produce an uneven distribution pattern across the surface. Production agriculture, they may be okay, but for turf, these hollow cones aren't for us. What we should be doing in turf is using these flat fan nozzles that produce a flat fan spray pattern. And within the flat fan family, there's different ones, and they're all effective, but you have to be careful and select the right flat fan nozzle and the right the spray tip code, and I'll go over that in a moment. But these are all very, very, very effective. Okay. Let's see. Oops. That. Okay. So one of the things is, as I mentioned, that hollow cone or raindrop nozzle, you want uniform coverage across the surface, and with those hollow cone patterns, you don't get a uniform coverage. So that's why we can't really recommend those. So nozzles affect the rate, the uniformity, the coverage, okay, and it's a major factor in how the product is placed onto the turf, okay. And again, nozzles aren't that expensive compared to the kinds of products that you put in that spray tank, all right. Common errors, the wrong boom height. I see this a lot. Misaligned nozzles. You want those nozzles, again, this is all part of the sprayer calibration program to make sure everything's working properly. You want those nozzles off-center slightly so that the spray pattern doesn't crash into each other, but basically sort of crisscrosses so you get uniform distribution across the surface. Nozzles do wear out. Okay, you should change them regularly. Do you change your nozzles, once a year, twice a year, a couple of times a year? They do wear out because of all the products and materials that we put through our sprayers. Different size nozzles used together on the same boom, that's going to affect the application rate. So you got to be careful there. But the wrong boom height, this is an interesting one. We'll get into this in a minute, but the boom height is related to nozzle spacing. Okay, so we'll talk about that in a moment. Okay, so droplet size and spray quality. There's a lot of physics that goes into this, and awful lot of evaluation of these droplets and how they relate to good coverage. Okay, here's our nozzles, our droplet sizes rather. We go from very fine to fine, medium. Let's see, very fine to medium to coarse to very coarse to extremely coarse. Very small very small droplet size, very large droplet size. Now, the smaller the droplet size, those droplets are more susceptible to drift. The larger droplet sizes are going to be heavier and less drift. So we want a good compromise. We don't want drift, but we don't want a very, very large droplet size either where coverage is poor. Okay, so this is what we have to think about. Now, when you look at a nozzle and it's rated for droplet size, not every droplet is the same. Half of those droplets are going to be a little smaller, half of them a little larger. But what's on the package or the product is the volume mean diameter. So if a nozzle is rated to provide a medium droplet size, that's basically the average droplet size. Okay, not every droplet's going to be the same. And again, we have these different droplet size categories, and there's a color coding sequence that goes with them if you're a TeeJet user, and other manufacturers have a color coding to relate the droplet size to the category there. So this is what I want to point out to you. This is something that just came out. They added more droplet sizes. This extremely fine is a new one, and this ultra coarse. Think of ultra coarse as being, just a super thunderstorm, heavy raindrops. Now, for applying fungicides in most, I think, turf products, we like to be in the medium to coarse to very coarse. That's the droplet size we go for. Medium to coarse, even very coarse. This gives us the best coverage, okay, minimizes drift, and we get the best coverage, medium coarse or very coarse droplet sizes, okay. You don't want to be in the extremely coarse range, or you don't want to be in the fine or very fine range, okay. So when think about that when you're selecting for your nozzles. And then again, I mentioned this color-coded system. Different companies have their own way of color coding these nozzles and nozzle tips. Now, this is what I want to again point out. Think about the pressure and the droplet size. So, if you decide you want to apply or use an 8005 nozzle, an XR 8005, but you want a medium droplet size. So to get a medium droplet size, your pressure has to be 40 psi. So kind of pay attention to these manufacturer guidelines. If you're using that kind of nozzle and you want a medium droplet size, you need your pressure to be 40. And this is, go through a calibration check, and you'll see that's the case. Okay. Avoid the fine droplet sizes. Stick to the medium or coarse droplet size, or even very coarse. Okay. So, let's see. The thing about droplets, and I don't want to, harp on this point. The devil's in the details, but it really comes down to we have to pay attention to these water droplet sizes, because now it's actually on the label. You're going to see more and more label language dictate or state on the label, apply these products in certain water volumes, etc., and it'll even tell you what the droplet size should be. In this particular label, it says use a coarse spray. So you have to figure out, you have to make sure your particular spray tip will produce that particular droplet size. Okay, that's not hard to do. So let's look at some flat fan applications and droplet sizes. And again, I just took some pictures here from a few years back. We have these are all flat fan nozzles. This is an XR extended range TeeJet. This will be considered your typical flat fan nozzle. The air induction nozzle, which I really like, and then the TurfJet. Now let me say something about the TurfJet nozzle. This was a compromise. This one was it produces an extremely coarse droplet size, but in a flat fan pattern. And this is a good nozzle to use maybe for some fertilizer applications. I would avoid using it for fungicide applications. There's other flat fan nozzles that can give us better coverage. Okay, but don't throw the TurfJet nozzle away. Keep that for other applications. So this is water-sensitive paper that you can get, and you could check the spray, the droplet distribution of your sprayer. You buy this paper. It's yellow and it turns blue upon contact with water. And so if you think about this, you have the flat fan, XR flat fan, air induction, TurfJet. These are three flat fan nozzles, okay, versus a hollow cone nozzle, the raindrop. And if you think about, well, which one's going to provide better coverage, you probably know the answer to that. It's it's either the XR or the air induction. Okay, these are the nozzles you want to go with. The TurfJet is okay. Well, we can do better. Okay, if that's the only flat fan nozzle you had, I guess that's okay. The raindrops, stay away from this one. You don't get very good coverage from that. Okay. So, and again, it relates to the water droplet size. So we did some research on this, and we're still doing all kinds of field tests and trying to really come up with some really good recommendations. We used a product here. It was a co-formulation of azoxystrobin and propiconazole, and we applied this product also by itself, and also we applied chlorothalonil, targeting dollar spot on a bent grass fairway. And what we did was I had to calibrate my little backpack sprayer to produce, and I used the different nozzles to give me a fine droplet size, medium, coarse, or extremely coarse droplet size. Okay, and so the question is, well, the droplet size provide us with a better way of controlling this disease. We counted the number of infection centers per plot, and we see the untreated had about 18 infection centers per plot. So this is a serious infection raging. And what it showed here was that, yes, using a medium or a coarse droplet size, that was our best bet when we're using a product like chlorothalonil or Daconil. When we use the Headway product, the co-formulation, again, the medium or coarse. The fine droplet size, the nozzles that gave us fine droplet size, too much drift. Those droplets were hung up in the upper canopy. We get an extremely coarse droplet size with the raindrops. We got some control, sure, but we can do better. We can do better with getting a nozzle that'll give us the medium to coarse droplet size. Okay, so coverage is important. Let's talk about spray angle. Okay, you got to have good overlap. Whether using an 80-degree spray angle or 110, it's your own personal preference. And you see how these nozzles are rated. They come with a numbering system. This 11004, it's a 110 nozzle calibrated to deliver 0.4 gallons per minute at 40 psi. This may help in your calibration. But think about pressure. You have to have enough pressure to form that spray angle. So you don't want to go 15 psi or 20. That's too low. Anyway, 30, 35, 40 psi is probably where you want to go. Enough pressure to get that spray angle. Okay. Now, this one I want to talk about nozzle spacing. So whether you're using an 80-degree angle or 110, what's important is the nozzle spacing, okay, compared to the boom height. And it should be in a 1-to-1 ratio. In other words, if your nozzle spacing is 10 inches, your boom height should be 10 inches. If your nozzle spacing is 20 inches, your boom height should be 20 inches. It should be in a 1-to-1 ratio. Okay, that will ensure good overlap and good uniform coverage. Okay, just keep that in mind. So I'll refer you to this TeeJet book. TeeJet.com. It's a user's guide to spray nozzles. It's more information than probably you need, but it's a good reference. A lot of it's for agricultural applications, but they have a turf and green industry section in there as well. So it's a great reference to have. You go on the website, you can download it as a hard copy or as a file for your computer. So definitely look at that. Okay, spray coverage again. It's a compromise. The best coverage are these smaller droplet sizes, right? But unfortunately, they're more susceptible to drift. And these raindrop nozzles give us very, very poor coverage, but those droplets are heavier, and they don't drift as much. Okay, so you have to think about that as you're selecting this nozzle. That's why I like the raindrops and turf jets. Okay, that'll give you drift control. So I like the air induction, even the turbo TeeJet. Those kinds of nozzles are better at reducing drift. Now, with every one of these nozzles, you're going to get some drift, but they're dramatically reduced with the air induction for sure, and sometimes the turbo TeeJet, depending on your pressure. So real quick, the air induction nozzles use this Venturi system. I like these nozzles a lot. The newer air induction nozzles do not have this extended tip because they break off a little easier. Basically, it's a great way to provide good uniform coverage while minimizing drift. Okay, the air induction nozzle. Let's see, and it gives you good uniform and excellent coverage. Here's an example real quick. Just want to show you a few photos. This is your standard flat fan spray pattern, your XR extended range or extended range cap. Any of these work well as long as you select the right extended range nozzle tip that will give you the medium to coarse droplet size. Okay, good uniform coverage. Your turf jet's a wide angle flat fan spray pattern. I like these. If you have to spray on a windy day, if it's 10 or 15 miles per hour wind and you have to be out there and spray, this might be your best bet for foliar fertilizer programs or soil type programs. This is probably a good nozzle. Don't throw this one away. But for fungicides, I don't like this one. I like the other nozzles, the other flat fan nozzles better. Basically because the coverage is not as good. Okay. You don't want those droplets hung up on the leaf tips. You want that material to uniformly get distributed throughout the canopy. The turbo TeeJet, this one is interesting because I wasn't sure about it at first. You talk to these agriculture engineers and they know a lot more about this than I do. But it has this sort of this spray tip that prevents clogging. And so guys that are that want to put 5, 6, 8 products in a tank to save time and effort, this might be your best bet. It'll give you a nice uniform spray pattern, and with that sort of orifice there, it minimizes clogging. So that's something to think about. Okay. Stay away from the raindrop nozzle. Again, very poor distribution. And this is basically what the hollow cones will do. You'll get poor distribution across that surface, and for green, that's just not acceptable in our industry. Okay, so bottom line, I don't mean to harp on this, but I think it's important. Effective coverage is important if you want these products to work the way they should. A couple of slides for you, just to drive home some points. Here's a chlorothalonil contact fungicide using a raindrop nozzle, and I use the combination of the nozzle and water volume. And if you look at the untreated check, we have an awful lot of dollar spot there, and none of these treatments really gave us good control. But if you're going to use a raindrop nozzle, the best I could get out of it was delivering it in 4 gallons of water per 1,000 square feet. Now that's ridiculous. Nobody's going to do that. But I'm just trying to drive the point home that if you're going to use this kind of nozzle or this droplet, this very extremely coarse droplet size, man, you need a lot of water to make that happen. Okay, so we can do a lot better. All right, the air induction TeeJet nozzle, again, this is on creeping bentgrass greens, and the 2 gallons of water per 1,000 square feet really helped us out. A little bit better than the one. I thought between 1 or 2, either one would work, but statistically 2 gallons of water per 1,000 was better. So here's a combination of water volume and nozzle selection that really helps. The Turbo TeeJet, again, you could statistically choose the best, but statistically not much different than 1. So 1 or 2 gallons per 1,000 might be an ideal water volume there. The extended range, your sort of typical flat fan spray pattern. Again, the trend here is on greens, 2 gallons is better than 1. Okay. And again, just comparing these at 1 versus 2 gallon, statistically you're not going to get much difference. So if you had to, you could get away with just 1 gallon of water per 1,000, but on greens, again, I prefer 2. So nozzle wear and replacement, again, what I suggest is when you buy nozzles for your sprayer, whether you do it at the end of the season or beginning of the season, buy enough nozzles, spray tips, and plus 1 or 2 more. Keep the unused ones on your desk, so when you check the other nozzles for wear, you can compare them to the unused one. Again, you want to be very, very careful. A lot of products that we use now and the materials the formulations and things could wear on these nozzle tips, and so it's easy and very inexpensive to replace these often, rather than putting 5 or 6 things in your spray tank and then having product failure. Okay, nozzle wear does happen, okay, and it can dramatically affect the application rate. Do a spray pattern check. I mean, just take a bucket or some kind of cup underneath each nozzle and run them through for a minute and just compare and see what the output is. Okay, you want them all relatively within 10% of each other. Okay. So, a couple of recommendations: choose a flat fan spray pattern for uniformity, good coverage. I like the air induction nozzles. I like your XR nozzles, your Turbo TeeJet, and other flat fan groups there. Avoid the hollow cone, raindrop. They're not going to get the uniformity that we need. Okay, avoid those. The Turf Jet, not the best for fungicides. Okay, because of the coverage issue. Air induction and others are better. And this just gives you an example. Like if your sprayer is calibrated at 40 psi, you'd want to select a 110.06 or a 110.08 to give you that medium to coarse droplet size. Just to reinforce that point, you got to kind of do your homework there and match up your pressure with your spray tip, and then go from there. Okay, and these handy charts are available from the manufacturer. Now, the other thing I want to talk about is spray carrier pH. Man, this is a topic that we're really getting into now. There's more issues involved in this than we think. It's a big issue in agriculture and with herbicide applications in agriculture, and how the the spray water and the pH of the spray water affects that product performance. Now, you know from class somewhere, the pH scale, you have the 0 to 14. 7 is neutral. Below that's acidic. Above that's alkaline, of course. And it's the alkaline pH that we worry about with fungicides. Okay, if most fungicides are stable in this 4 to 6 range. If you get 7.5, 8, 8.5, some of these fungicides can start breaking down due to alkaline hydrolysis. Dialox and insecticide is a good example of that. Some of our fungicides are polyoxin D and thiophanate methyl. These fungicides break down if it's sitting in water with a higher pH. So refer to your MSDS sheets for pH stability information because every product is different. You look on the MSDS sheet, it shows you the optimum pH range. So for this particular product, if your spray water pH is 8, 8.5, in the tank, that product's going to break down. Then you go to apply it, it's not going to work, and you may think you have resistance issues when you really don't. Buy yourself a pH meter. They're relatively inexpensive. I don't know how often you may check the pH of your spray water, or if you take your water and send it off to a lab for analysis once in a while to get checked, something you definitely should do. This is an example from a golf course in Pennsylvania here. They had some issues with their irrigation water that they use for making their applications, and you can see it changes on a monthly basis, and it starts out acidic, but as you get further into the season, it gets more and more alkaline, and this is due to the high bicarbonates in the water. So here he is in August using pH water 8.5 in his spray tank, and he was having some problems with some of his fungicide performance. And it came down to and the only way he knew this is once a month he would take a water sample, send it to the lab for analysis, okay, which is not that expensive to do. This is a quick little study I did for the Rutgers Field Day event. I took thiophanate methyl, not to pick on this one, but it does have a pH issue. I had spray water with a pH of 5, a pH of 7, and a pH of 9. I mixed the material in the spray water, let it sit there for about an hour, maybe 2 hours, and then I made the application. And sure enough, the product, the dollar spot control is breaking down under that high pH. Again, just to reinforce this point that check the pH of your spray water. Okay, so other things, surfactants and wetting agents. We add so many things to our spray tanks. What is that doing? The only thing I want to say with surfactants and wetting agents, be careful when you use some of these that the spray angle doesn't collapse. If you're using a 110 nozzle or 80-degree nozzle, make sure you have a 110-degree or 80-degree flat fan pattern. Some of these materials may collapse the pattern, and you're not going to get good overlap and good coverage. So be careful of those. Okay. Let's talk about fairing for a minute. I have to say something about this. This has been a big issue over the years, and one of the best things you can do when you're making fungicide applications is volume and coverage. Real quick, this is from a Perennial Ryegrass Fairway in Pennsylvania, and what it shows you here is we use these products, the two fungicides, Heritage and ProStar. We use them alone, tested them alone, and with a soil surfactant, Revolution. Okay. So here we definitely recommend using a surfactant. Using a fungicide by itself will get improved control, but adding the surfactant's even better. And then when you use a higher water volume, you get even better control. Okay, you're more or less rinsing the material in to getting it to the target site. These basidiomycetes are down in the root zone in the thatch. So here's where water volume will help. Now here I would recommend any flat fan nozzle, good uniform coverage across the surface, but a higher water volume to help with the uniform coverage. Okay, and this is Dr. Frank Wong in California. Did a similar study on creeping bentgrass green with similar results. See with ProStar, it's fine by itself, better with a surfactant, and even better at a higher water carrier volume. Okay. Post-application irrigation, again, what I mentioned here is just you want to rinse the product in. You don't want to drown it through or push the product through. More or less rinse the material into the thatch and into the upper root zone. Okay, so you don't over-apply, don't under-apply. For fairing, I don't want the fungicide to get absorbed by the plant. It's counterintuitive. I want that fungicide to bypass the plant and get down into the thatch. Okay, You want to knock off some water off the leaf tissue, get it into the crown. Maybe a quarter of an inch might help. For some of the soil drenching, you might need a quarter inch to a half inch, and you're going to have to determine that on your own, how many turns of the irrigation head you need to make that happen. Okay. The other thing I want to say real quick about, I was asked to talk about the impact of rainfall on dollar spot efficacy. Again, you obviously want to avoid making applications in the rain or if rain is forecast, because these fungicides do behave a little differently. Here you have Daconil, chlorothalonil product. It's obviously better, more efficacious when you apply it in a rain-free environment. With a product like Chipco 26GT or Prodione, it has more rain fastness. You can get away with making an application if you know, and it rains a little bit after. But again, be on the safe side. Try to avoid these kinds of applications when rain's forecast. Okay, so bottom line here, water carrier pH is an important factor to maximize fungicide efficacy and performance. Some surfactants and wetting agents can improve fungicide performance. Say if you're going after some of these root diseases in fairy ring. Post-application is important for fairy ring type diseases, maybe summer patch and other root diseases. Okay, so these are some of the things that we want to continue to explore, to continue to provide good recommendations to improve these product applications and performance. All kinds of websites out there for you to look at. Obviously, the Bayer folks have an excellent website packed full of information backed by Bayer and others. A shout out to my colleague, Dr. John Kaminsky, and I know Dr. Frank Wong was involved in this too. This turfdisease.org website, excellent source, and many others. Okay. Real quick, I know I'm running up on time here, but what's new? Some exciting things. The air induction extended range spray tip, say that 3 times fast. All kinds of technology involved in this tip. Using some kind of ultra-high molecular weight polyethylene. I don't know what that means, but evidently it's more resistant to abrasion, especially for some of these wettable powders. So that could be good news for us. So these AIXR flat fan spray tips are a little dense, a little more compact, so they won't break off as easy. Then we have this air induction twin spray, very popular in post-emergent herbicide applications in agriculture. Maybe that's something we could look at for crabgrass, post-emergence crabgrass control here. Again, all designed for improved coverage. This XP Boom Jet, this one might be interesting. It looks kind of different, and the spray pattern's a little different. It almost provides a uniform spray pattern across the surface there, but this is where it might work as a boom extension or as a boom replacement. If you're trying to reach areas beyond the fairway, maybe into some roughs and some native areas, that might be your best bet. So something to think about. GPS technology, there's a tremendous amount of this technology in production agriculture, starting to filter down into turf now. Of course, we need things a lot more precise. We don't deal on an acre basis. We're dealing on 1,000 square foot or square foot basis. So we're starting to see swath guidance modes and things for fairways and greens. You might see more of this coming through the pipeline over the next couple of years. What's interesting about this boom selection control, this might help some fungicide costs. You have to spray the fairway, but maybe that section of the boom can shut off when the boom extends beyond the fairway, so you're only spraying the fairway and not the roughs. Maybe you'll save a little there on fungicide applications. So that kind of technology is coming through the pipeline, and I think it's going to get more and more easier and more affordable for us in the green industry. Okay, this data mapping, variable rate technology. This has been a tremendous amount of work at Oklahoma State looking at this, and it's very information intensive, making applications where needed, that kind of thing. So again, GPS automatic steering. If you're talking about 8,000 acres, you need to drive in a straight line. On fairways and greens, well, you still need to drive on a straight line, but hopefully we train our employees to do that for us. But this kind of technology is available now, and everything's going to become wireless, of course, and you can check your cell phone or your BlackBerry or your iPhone and make things happen for you. So anyway, I appreciate your time. I think I'm going to send this back to Mr. Johnson now. I think we're almost sneaking up on our time. I'm excited about this topic. I can talk about it for a long time, but I appreciate your patience, appreciate your time today. And Mr. Johnson, I'm going to hand it back to you.
Thank you, Dr. Fidanza. It's a very good presentation and very in-depth. Just a reminder, if anyone has any questions, just go and type it into the Q&A and we'll respond. While we're looking for those, one question, we saw some of your work on water volume with chlorthalonil. What would your recommendations be for some of your systemics and local systemics like the strobilurins and the DMIs on water volume?
Yeah, I would stick with that recommendation of on greens, go with 2 gallons of water per 1,000. I know some of the work showed you could get away with 1 gallon per 1,000 on greens, or maybe 1.25 gallons of water per 1,000 on greens with some strobies or your DMIs. But I like to err on the side of caution, get a little higher water volume on your greens to ensure good uniform coverage. Now for fairways, yeah, 1 gallon per 1,000 is fine. That's 44 gallons per acre. Again, I like to sneak that up to an even 50 gallons of water per acre, just to get good uniform coverage.
All right.
Yep.
Do we have any other questions from our audience?
Well, Mr. Johnson, one of the things I know, I get a lot of questions about this GPS technology and all that, and it's when you go to the GIS show this coming February, look around, visit these various companies like John Deere and Toro and some others, and you can see this kind of technology kind of working its way onto these sprayers now, and we'll have to sort of dial that in to just see how we can sort of improve our applications and improve product performance with these kinds of technologies.
Okay.
Go ahead.
We've got a question, and it's for take-all patch in St. Augustine. What nozzle and spray volume is recommended? They're spraying Heritage.
Okay.
And he also adds brown patch.
Okay. Well, think about this: brown patch, Ryegrass blight, foliar disease. Take-all, that's going to be organism fighting you below the surface. What I would do, with the nozzle types, go with air induction nozzle to minimize drift, or a turbo TeeJet or XR, any of those flat fans. Okay. I would go probably 1 gallon of water per 1,000 square feet for Ryegrass. Going after take-all, I'd probably still go with 1 gallon of water per 1,000. If you can go 2, great. But with take-all, perhaps if you can do a post-application watering in, sort of to rinse the material down into the crown, try to get it into the root zone. With brown patch, you don't want to water it in. You want that plant to you want that material to sit there in the canopy. So I would go with 1 gallon per 1,000, and again, air induction. I like the air induction just because it minimizes drift. The XRs are fine. The turbo TeeJets are fine. There's the turbo twin jet. There's the turbo drop twin. Any of those are fine, as long as you select the right nozzle tip that gives you the medium to coarse to very coarse droplet size. You get into the fine range is drift. You get into the extremely coarse range, you get poor coverage. I know it's a lot to flush through, but it comes down to the droplet sizes on these products.
I have a question from Mr. Carl Brown. What can be done to manage pH in application water effectively?
Oh, that's a good question. There's several products out there, the pH buffer products that you can buy. I know here in southeastern Pennsylvania, some of our local distributors have these sort of pH buffer products that will adjust the pH of your spray water. Ideally, what you should do, you have your water that you fill your tank up halfway, you add the products, you fill up the tank the rest of the way, and ideally take a measurement of the pH of that spray tank water, okay, with all the products in there, and see where you are with the pH. before you add the products, and then after. If you need to adjust the pH, there's these kinds of products that you can buy. They're relatively inexpensive to sort of buffer that pH, get it into that 6 to 7 range. I mean, ideally, that's what you need to do. If your water is high in bicarbonates, that's going to drive the pH up. I mean, there's not much you can do sometimes to correct your irrigation water or your spray water. But just in the spray tank, you can use these kinds of products to buffer that tank. So always have that on hand. If you don't have a pH tester, you can buy those little pH strips. You sort of dip them in the solution and they change color. But to me, they're kind of a pain. If you can invest for $50 or a little bit less, a little bit more, buy yourself a pH meter and manage that effectively.
Very good. Well, we're to keep us on time, I'll go through the reminders here at the end, and while I'm doing that, if there is any other questions, we will try to get to those. But again, I just want to thank Dr. Fidenza for an excellent presentation and remind everyone who is interested and can join us on November 15th at 3 p.m. Eastern Time for a presentation with Dr. Billy Crow. And, of course, for those of you who are members of GCSAA and wanting credits, you can expect your information within the next 6 to 10 days. If you do have any issues, contact Veronica on the email address that you see here. And, again, I want to thank you. Let's see. I think we may have a couple more questions here while we were going through that. Here's one, and it's from Jimmy Thomas again. For take-all patch and home lawns, watering right away is difficult. Yeah. If the homeowner is not able to water in immediately, can increase the spray volume to the point where watering into the thatch is not required?
Yeah, that's a good question. I think so. 2 gallons of water per 1,000 minimum, kind of treat it like Fairway. 4 gallons of water per 1,000 would be better. 150 gallons per acre, 180 gallons per acre. If it's a home lawn, if it's a small enough property, hopefully you can move that much water across it. And or if you say your sprayer is calibrated to 100 gallons of water per acre, maybe go in 2 directions, that kind of thing, to kind of get the water volume that you need. So I think in the absence of post application irrigation, increasing it 100 150 gallons per acre, I think that's a good bet.
Good. I've got a follow up to that question then. How many hours, with your experience, would you give if they can't water in immediately to water these products in for diseases that are in the crown and in the soil?
Yeah, I tell guys for fairy ring, you water in immediately. You can't, if you're going to spray it across a fairway or green, but by the time you drive your spray rig back to the shop, have a cup of coffee, make a few phone calls, and then you remember to turn on the water, that's too late. I really don't want that material for fairing being taken up by the plant. So water that in immediately. I mean, as soon as you drive off the green, have somebody turn the irrigation on. But for these other diseases, again, I think it varies for some of the summer patch and take-all patch. I mean, you have some more, you want that product to be taken up by the plant. So ideally you can irrigate right away. You should irrigate right away, but if not, I mean, I wouldn't wait a day or 2 days. No, maybe an hour or so you might get away with it. But if, just to be more effective, turn on the water and sort of rinse it. I use the term rinse. That's from my buddy Stan Zontek at the USGA. He came up with that term, rinsing it in. So I have to give him credit. You want to rinse the products into the crown, into the root zone as soon as you can. I just don't want that product sitting there being taken up by the plant, moved up the xylem to where the organism, the pathogens, is not hanging out. You want to get the product to where it has to get to right away or as soon as possible.
Very good.
Okay.
Thank you again, and thank all of our participants, and hope everyone has an excellent fall, and gets the adequate rainfall, because I know we've had experiences on extremes all across the country this year. So everyone take care, and thanks again.
All right, thank you.